Today we will cover two chapters, chapter 3 and chapter 4. Both chapters are quantitative part, some calculation. Maybe about 3 hours. Too long? Let's try. Sometimes if I go fast, then some complain too fast. So, okay. Chapter 3, project management. Project management. We use many times, and you heard many times, project, right? Next page. Okay. If I want to build a house, maybe myself, maybe ask somebody. So, what should I do? Suggestion. What's first I should do?
Call a general contractor.
Contractor. Okay, and then?
Decide, yeah. What house?
Mm-hmm. What house?
What
Kind of
specifications,
plan, right?
yeah.
Blueprint.
Mm-hmm.
Okay. What else?
Resources,
What kind of resources?
like materials,
Mhm.
who's gonna do what.
Mhm. Okay.
Lumber, nails.
If I'm first, I will search the place, right? Where?
Get you some
Oh,
land.
where,
right?
exactly.
Hmm?
Mm-hmm.
Like if I build a house in Phoenix City,
Mm-hmm.
then I don't know where is like safe, and then in terms of the price and neighbor. So search place, right?
Mm-hmm.
If I decide in a certain area, okay. First I decide the place. Okay. Next. Decide types of house or whatever,
Style.
right? Style.
Mm-hmm.
Style. Right?
Okay.
Mm-hmm.
Okay. What else?
Size.
I need money, right?
Yeah, you need money.
Finance, right?
Yeah.
Okay, what else?
Now you go to the
Now
actual contracting
Contractor.
people.
Contractor, yeah.
Okay. And buy land, right?
Mm-hmm.
Spot or let's say land.
Mm-hmm.
After that, maybe need permit.
Yeah.
Yeah.
Right.
Definitely.
After that, maybe contractor start digging, right?
Right.
Dig.
Okay. What else? Next,
Then he,
Concrete.
foundation,
foundation.
foundation.
Then
Plumbing.
such.
Yeah, exactly.
Okay. This is project, right? I want to build a house. Even I want to buy a house. Many things, right? I should do, right?
Mm-hmm.
So project. Definition of projects. An endeavor to accomplish a specific objective, building a house, right?
Mm-hmm.
Through a unique set of interrelated tasks, right?
Mm-hmm.
Such, and the effective utilization of resources. Why? Why we need effective utilization of resources? Why we need?
That's to do it quick, fast, and cheap.
Operations management, right?
Mm-hmm.
Make it better, cheaper,
Cheaper,
faster.
faster.
Mm-hmm.
That means I need a house faster, right?
Mm-hmm.
Cheaper, good, right? And then nice house, quality, right?
Right.
Better. So project management is in operations management, using resources. And the project itself is a series of related jobs. Usually directed toward some major output and requiring a significant period of time. Usually, normally, they said 4 months is to build a house, right? 4 months is. So we sign a contract. They said 4 months is. If it delay, whatever reason, and then 6 months is, that's the problem.
More money.
right?
Mhm.
And then wait,
Mm-hmm.
and something problem, right?
Mhm.
So, in a project, time is very important, time. And also, it says interrelated tasks, related each other. Okay, if I buy a land, but can I dig? No. Before I have money, or before I have permit, can I dig?
No.
No. So something first, something next, and so on, related. That is project and project management. Management, including management, project and management. Doing project related works, jobs, how? Better, cheaper, faster, right? It says project management is the management activities of planning, directing, and controlling resources such as people, equipment, materials to meet the technical cost and time constraint. In certain constraints, make it better, cheaper, faster, doing project. That is project management. That clear? Yes, clear?
Mhm.
Good? That is project management. I told you such jobs related, right? Related. Something first, something next, and so on. Interrelated. Then bring up the blank page. Like this. Find a place first, right? Then need something style, decide the style, like first one story or two
Two
stories,
stories.
something like that. After something then decide maybe simultaneously do something. After that, something, after that, something, and together something, and something like this, right? Looks like network, right? Looks like network. So they are related each other, and then there is kind of sequence. First thing, next thing. So they, if I draw their relationship, looks like this network, right? Then so project activities are related each other. Then we draw, then it looks like a network, right? So we use network planning models. Network planning models for project management. A project is made of a sequence of activities, first thing, second, next, and so on. Looks like a network. And then in project management, time is important. I told you, right? So how can we make it faster? Using these models. Then in network, there are passes. I will tell later again. Then longest is critical path. Longest path is critical path. And also, we call this network planning models as critical path method because certain path is critical. So manage that path first. So we call that CPM, critical path method. Our textbook introduced three types of critical path method. First one is critical path method with a single time estimate. Second one, critical path method with 3 activity time estimate. And the last one, time cost models. Time cost model. Usually, first two critical path method, if we have time information only, time. To do this job, certain time information only, then we can use critical path method. First one, second one. And then last one, time cost. If we have time and cost information, we can use this time cost models. Our textbook called this one time cost models, other textbook, and then usually we call PERT, P-E-R-T. This one stands for program. T stands for program. E, evaluation. R stands for review. T stands for technique. Program, sometimes project, but usually program. Evaluation, review, technique. So other textbook or usually if we have time and cost information together, then we use this model first. So many times when we say about project management and then what method we use, PERT and CPM. We call PERT and CPM. So CPM is this one, critical path method, and PERT is this one, program, evaluation review technique. First, method, critical path method, first one, with a single time estimate. For this class, time is fixed, right? From 6 in Eastern time, 6 to 10:20, right? It's a certain time, we know time, right? But sometimes it's not certain. But anyway, we know maximum, like this one is later. Anyway, you know the time, right? From 6 to 10:20 for this class, right? So time is certain, we know, then we use this single time estimate. Using this method, we can get total project time to finish certain project, many activities, how long it takes. Okay. Example, this project consists of 1, 2, 3, 4, 5, 6, 7 activities. And we denote each activity like A, activity B, activity, and so on. And then this column, immediate predecessor. First activity, access customers' needs. First one, activity A doesn't have immediate predecessor. That means activity A is starting point of this project. And then activity B, write and submit proposal. Immediate predecessor is A. That means after A, activity A finish, then this one can start, like that. Before we dig, we need permit or something, right? So to do this one is first. Like this, to take this class, you need something, right? Prerequisite, right? So this one, to do this one is kind of prerequisite, predecessor, okay? And C after B, D after C, E after C, F after D and E, something like this. And then each activity time, certain. Only single certain time we know. Then we can use this method. Using designation, immediate predecessor, and time information, we can draw network diagram like this. I need more space. Okay, I will do up there. Okay. Activity A doesn't have immediate predecessor, so activity A is starting point, right? Then activity B from A, right? B. And C from B, right? D from C, right?
Yes.
and E also from C. And F from D and E together. And G from F, right? So, and then inside of this knot, when we draw network diagram using circle, knot, then designation, and then time, with activity time, then using arrow where it's from and then where it goes. So, if we draw this project, this diagram, network diagram, fancy, looks like this. Easy, right? Question so far?
Yeah.
Okay, good. So using designation, immediate predecessor, and time information, we can draw like this. And then to find project time, total time, we need something. Determine early start and early finish time. On top of knot, early start time, early finish time. Later, late start and late finish. Get this. Activity A is starting point, right? Start time is 0, right? And then use 2 weeks. So finish time is 2. Activity B can start after A finish, right?
Right,
So starting point is 2, right?
right.
Then use 1 week 3. C can start after B, so starting point is 3, and use 1, 4, right? Then D and E also, their starting point is 4, 4 after C, right? Then use 2, use 5, plus 2, 6, plus 5, 9, right? Okay, F can start after D and E finish, right? D finish at 6, but this one still work, right? So wait until later ones finish. So starting point is 9, right? After finish this one, plus 5, 14. And then 14 and 15. So start time, finish time. I will tell you why it's early start, early finish, or late start, late finish later. So far.
Here's a long one. So you pretty much made up the weeks, right? The time,
Mm-hmm.
you made up the time, right? Where did you get the time from?
Time given from the chart.
Yeah, but I was saying that time.
Time is
you just-
given.
You just created that time on that chart, right?
Given.
Okay, that's all.
Mhm.
I mean, I came in later on that chart.
Okay. Then next step. Determine late starts and late finish time. It says backward. To find late start, late finish time, backward. So total time is 15, right? just same. 15 minus 1 is 14, right? Then go back. 14, 14, right? And then minus 5 is 9. 9. Okay, so far, no problem. 9, 9, right? This one goes there, this one goes there. Minus 2, 7, minus 5, 4. And for this one, there are two different late start times, 7 and 4, right? Which one you would take? Earlier one. Okay, when you go this way, earlier one.
The early one.
When you go this way, 6 and 9, later one. Okay? Do you know what I mean? Then 4, 3, 3, 2, 2, 0. So either way, to find early start, early finish time, go this way. If you have two numbers, go this way, early start time, later one. If come this way, backward, if you have two numbers, earlier one. I will tell what's the early start, early finish time. Okay. The total time is 15, right? 0, 5, 10, 15. Activity A start from 0 and finish
At 2.
2, right? This is A. And B start at 2, right? And finish at 3. B, right? And C, 3 and finish at 4, right? Then D and E start at 4. D is
Yes.
2, is it 4, right?
Yeah, D go to 6. Right.
6, E. But E goes to 9, right?
Yes.
And F and G 15, right? A, B, C, E, F, G, they cannot delay. If this one delay, then delay, right? This one also, if this one delay, then entire project delay, right? But how about this one?
That one got like
That
3
one can be
weeks.
delayed,
Got 3
cause
Yeah.
extra weeks.
you can't
So,
start to 9
activity
anyway.
activity D,
Mm-hmm,
if activity D starts at 4, finish at 6, right?
mm-hmm.
Okay. Because this one is 9, right? And if this one start at 5, finish 7, right? Because it used 2 weeks. 6, 8, 7, 9, right? If D start 8, then delay, right? So, possible and feasible start and finish time for D, there are 4 sets, right?
Mm-hmm.
So, this one is start time, this one is finish time, right?
Mm-hmm.
Mhm. Among start times 4 and 6, early start time, early finish time, right? This one, start time, finish time, late start time, late finish time. Allowed start
exactly.
and finish times. Among them, maybe this one, early start, early finish. Late start, late finish. Others, this one, others, there is no allowed, right?
Right.
It's tight, right? So this one delay, then entire project delay. This one delay, and so on, right? Only activity D has something allowed or spare time, right?
Flexibility, yes.
This one. Quiz number 1 from chapter 3 and 4, calculation, right? But quiz number 3 from quiz chapter 1 to, I changed it, chapter 12. Question type is true or false, and some multiple choices. So, question type like this, true or false type, for quiz number 3. I will
Oh.
tell about that later again.
Right.
Okay.
False.
Critical path is the shortest sequence of connected activities to the network. True or false?
False.
False, because
It's the longest.
longest, right? So answer is false like this because of this one. And next one, slack is the time each activity can be delayed without delaying the entire project. Slack. Something spare time, like an activity D. Activity D has there are 4 sets of allowed start and finish time without delaying entire project, right?
Mm-hmm.
The spare time is slack. Slack equals late start time minus early start time, or late finish time minus early finish time. Activity D, 4, 6, 5, 7, 6, 8, 7, 9, right? Early start time, early finish time, late start time, late finish time, right? So, for activity D, slack equals, slack for activity D equals
6 minus 4.
LS, late start time, late start time 7 minus early start time 4, or late finish time 9 minus early finish time 6, that is 3, right? So activity D has 3 weeks of slack. That means 3 weeks of spare time, allowed time without delaying entire project. That is slack. Okay? Make it clear. Clear, right? So far, question? Okay. In a project, many activities related and network like this. There are 2 passes in this project network diagram. There are 2 passes. One is A, B, C, D, F, G. A, B, C, D, F, G, and the other one is A, B, C, E, F, G. There are 2 passes, right? Okay. Critical path is longest, right?
So number 2.
When you determine which one is critical path or which one is non-critical path. First method, this one doesn't have slack. There is no spare time, right? If this one delay, then delay, right? This one doesn't have. Then look at this, 0, 0 to 2, same, right? Early and late start and finish time the same. That means there is no slack, there is no spare time, right? So they cannot be delayed. If they are delayed, then entire project delayed, right? No slack, no slack, no slack, no slack, no slack, right? So this path consists of all critical activities. If there is no slack, that is critical activity. Critical. If they are delayed, then entire project delayed. So they are critical, right? So all activities are critical. But on this path, first path, D has slack. That means this activity is not critical. So we call this non-critical activity. If the certain path include non-critical activity, that is non-critical path. If a path has doesn't have any non-critical activity, or certain paths consist of all critical activities, that is critical path. You know what I mean? So this one is critical. Second method to find critical or non-critical path, adding activity times. First one, 2 plus 1, 2 plus 1 plus 1 plus 2 plus 5 plus 1 equals
12.
12. Second pass equals 2 plus 1 plus 1, 5 plus 5 plus 1 equals 15. 12 and 15. Between this one and this one longer and longest, right?
Yeah.
So critical path, longest path, right? So this path, this one is critical path. And always duration of critical path is the same as project time. 15, 15. Okay? So when you take quiz and final using this method to find the critical path, first you need to determine what passes are there, 2, 3, sometimes 4, 5. Among them, which one is longest? Using this method, add all activities, time, then longest one is critical path.
And total project time.
That is the same. Question? Okay. You have practice problem 3-1. Practice. Do it.
Oh, now?
Now, do you want me to give you this one as homework? No. Do it. This class, there is no homework. Instead, in-class practice problem. So, don't bring something home. Just handle everything here. Okay? Just try. At the end of the lecture notes, you have.
Oh, okay. Oh, good.
Try.
Yeah.
Where is it?
I told you I will provide everything.